Hello, we are in Chapter 4, Section 4.8, Polynomial Division. In this video, we're going to go over problem number 7, in which we are to divide the following polynomials with the hint to make sure that polynomials are in descending order and look for missing terms before dividing. We acknowledge that the divisor is already written in descending powers. Therefore, we write it as is 2x plus 4. But in the dividend, we have to rearrange since it's not written in descending powers. 6x to the fifth is the leading term. Then, there is missing fourth power of x, so we have to add 0x to the fourth. Then we have minus 16x cubed plus 6x squared plus 8x, and then plus 20. And I like to add those vertical bars to identify the columns of proper degrees in my division diagram and label them for easiness of recognition and addition in the process. So we start with degree 5 and go down to end with the constant term. We identify the leading term of the dividend 6x to the fifth and the leading term of the divisor 2x and perform the division of those accordingly. I like to keep things written down here on the side. 6x to the fifth divided by 2x. Their simplifications gives us 3 and x to the fourth. That's of degree 4, so we write it in the proper column of the quotient area of our diagram. Multiply this newly obtained term of the quotient by the whole divisor by distribution, giving us 6x to the fifth and plus 12x to the fourth. We have to subtract it from the current dividend, so we multiply it by -1 and write it that way. That gives us minus 6x to the fifth minus 12x to the fourth. And we have to keep track of those columns of proper degrees. Perform the addition. 0 minus 12 is negative 12x to the fourth, and I rewrite everything else down so I don't lose anything in the process. Acknowledge that the degree of this result is 4, which is not less than 1, the degree of the divisor. Therefore, I need to perform another division step with our result as the new dividend, whose leading term is negative 12x to the fourth, and we divide that by 2x, the leading term of the divisor. We simplify it to get negative 6x to the third, which is obviously of degree 3, and that's where we put it in the quotient, and multiply that newly obtained term of the quotient by the whole divisor 2x plus 4 by distribution to get minus 12x to the fourth and minus 24x cubed. We multiply that by -1, again since we have to subtract it from the current dividend to make it an addition, to make it easier. So we get plus 12x to the fourth and plus 24x cubed. Minding the columns of proper degrees, we write it down under the current dividend and perform the addition. The first two terms simplified, and negative 16 plus 24 is positive 8, so we get 8x cubed, and I rewrite everything else not to lose it. Acknowledge that the degree of this result is 3, which is not less than 1, the degree of the divisor. So I have to go through another division step with our result as the new dividend, whose leading term is 8x cubed, and that 8x cubed is divided by the leading term of the divisor, 2x. We simplify, 8 over 2 is 4, and then we're left with x squared. That's of degree 2, and that's where we put it in the quotient area and multiply that newly obtained term of the quotient by the whole divisor, 2x plus 4, by distribution to get 8x cubed, and then plus 16x squared. We multiply that result by -1 since we are to subtract it from the current dividend. So we get minus 8x cubed minus 16x squared. We write it down in our diagram under the current dividend, minding the proper columns. For easy addition, we perform that addition. The first two terms simplify. 6 minus 16 is -10x squared. Write down everything else, plus 8x plus 20. Acknowledge the degree of this result as 2, which is still not less than 1, the degree of the divisor, so we have to perform another division step with our result as the new dividend, whose leading term is -10x squared, and is divided by the leading term of the divisor, 2x. We simplify to get -5x, which is of degree 1. That's where we place it in our quotient area of the diagram, and multiply this newly obtained term of the quotient by the whole divisor, 2x plus 4. By distribution to get -10x squared minus 20x. We multiply it by -1, again since we are to subtract it from the current dividend. We get plus 10x squared and plus 20x. Minding the columns of proper degrees, we write it down in the diagram and perform the addition. The first two terms simplify. 8 plus 20 is 28x, of course, and then plus 20. The degree of that result is 1, which is still not less than 1, the degree of the divisor, so we have to perform another division step with 28x plus 20 as our new dividend, whose leading term is 28x, and is to be divided by 2x, the leading term of the divisor. 28 over 2 is 14. That's all that we get from this division. 14 is of degree 0 as a polynomial, so a constant term of our quotient. But that constant term, this newly obtained term of the quotient, is still multiplied by the whole divisor, 2x plus 4, by distribution to get 28x plus, well, what is 14 times 4? 56. And since we are to subtract it from the current dividend, we multiply it by -1 to get minus 28x minus 56. Write it down in our diagram, again minding the columns of proper degrees. Perform the addition. The first two terms nicely simplify. Then 20 minus 56 is -36. As a polynomial, that's of degree 0, which is finally less than 1, the degree of the divisor. So we're finally done, and negative 36 is our remainder. It means we already have the complete quotient as well. And it's just a matter of writing the result of our division in the form quotient plus the remainder over the divisor. The quotient is 3x to the fourth minus 6x cubed plus 4x squared minus 5x plus 14, and then plus the remainder negative 36 over the divisor 2x plus 4. And we are going to keep this that way even though that final rational expression negative 36 over 2x plus 4 can be simplified a little bit because we have a common factor of 2 in both the numerator and